Hello students, and here we are going to cover the topic where I am going to explain you how to graph the first and the second derivatives from the original functions. So on this slide you can see that there is a graph given to you. For example, this is the graph which represents the function f of x. Now before we start graphing, there are few things which you should keep in your mind, that what is meant by what happened at f prime of c. It means what happened at the derivative. What is the behavior of the function at the derivative? So first of all, you must know there are critical numbers which you should keep in mind, and we get the critical numbers at relative extrema. It means we have relative minimum and relative maximum. We will get the critical numbers. Now, what happened at the critical numbers? At critical numbers, whether the first derivative is equal to 0 or the first derivative is undefined. So if the first derivative is 0, it means we are going to have the relative maximum with the smooth curve or a relative minimum with the smooth curve. But in case of the derivative, undefined derivative, it means we are going to have the sharp turns where the slope of the tangent line is undefined. And here, if we have the curves like this, smooth curves, so at this points, this is the critical point, here the critical point, and at this point, what is happening? That the slope of tangent line is 0, because the first derivative is also termed as the slope of tangent line. So after doing this, there are some more things which we have to keep in mind. If the first derivative is greater than 0. It means if this first derivative is greater than 0, so we would have the positive slope. Or you can say in other words, wherever the function has a positive slope, the derivative you will draw above the x-axis. Above the x-axis. You will show the graph above the x-axis for the derivative. Now, if the derivative is negative or the graph of the function is decreasing, or so f prime x is less than 0, you will sketch the graph below the x-axis. So these are the basic things you should keep in mind. Now, how to start? So the starting point is that find out wherever the critical points or the slope of the tangent line is 0. So here you have the slope of the tangent line 0, and at this relative minimum you have the slope of the tangent line is 0. Now check, here the slope is 0, here the slope is 0. What do? Go down where you expect to draw your derivative curve and just sketch those points, just put those points on the x-axis, because where slope of the tangent line is 0, it means those are your x-intercepts where the y is 0. After doing this, now check what is the behavior of the slope one by one. So here, look at this curve on the left hand side, this curve, okay, on the left hand side you can see this curve. So what is happening on this curve and where the slope of the tangent line, how does the slope of the tangent line looks like? So if I sketch the slope here, the slope is positive. Anywhere if I sketch the tangent line, my slope is positive. Everywhere my slope is positive. So if the slope is positive, it means I am going to sketch the graph somewhere above the x-axis. So the left side, let's check here. So the left side should be above the x-axis. So like that. Now let's see the second behavior. Okay, so here from the first intercept to the second intercept, what is happening? So if I sketch the graph here, if I sketch the slope here, here everywhere the slope of the tangent line is negative, right? The slope of the tangent line is negative because it is decreasing everywhere. So slope of the tangent line should be drawn as a derivative below the x-axis. So I can say the graph is like this. Just draw a freehand curve. Now, what is happening in the end? In the end, the graph is increasing. Now, the graph is increasing, or if I try to sketch my tangent line, I don't know, it's not sketching right now, my hand, my drawing, it's okay. If I try to sketch here, okay, the tangent line, I could see that the slope is positive. So the slope is positive for all the tangent lines. The slope is positive. So positive slope means that it should be drawn above the x-axis like this. So this is how we try to sketch the graph for the derivative of a function. Now here I have the same graph. I have the same graph, the function for the function f of x. Then I want to sketch the graph for the second derivative from my original function. I want to sketch the graph for the second derivative, keeping in mind the same concept, but applying the concepts for the second derivative. So, in the second derivative, I should find first of all my inflection points. I must get my inflection points. Why I should get the inflection points? Because at inflection points, my second derivative is equals to 0. And those inflection points then will be my x-intercept. Yani the inflection points which I will get from the function will be my x-intercept in the second derivative's graph. Now, another thing, after that I have to see where my curve is down. So for the down curve, I should know that the second derivative should be less than 0. Which means if I would have a negative slope, if I would have a concave down, okay, concave down will be drawn below the x-axis. Below x-axis. Now, if I have a concave up, it means the second derivative is greater than 0, which means that this is my concave up. So I will draw above the x-axis my curves, keeping the same context. Now, what are inflection points? So first thing is try to find out the inflection points. So inflection points are the points where the concavity changes, means concave up changes into concave down or concave down changes into concave up. So look at the graph here. This is concave down and this is concave up. So somewhere here is my inflection point or here. So go down and that inflection point, draw it below here, this somewhere here, right? So this point is my inflection point because I am trying to sketch the second derivative graph. Now here this curve, okay, this curve. This is what? Concave down. So concave down should be below the x-axis. It means here, below the x-axis. Okay, now second curve on the right hand side, this can be all concave up. So concave up is my above the x-axis. So this is how my graphs look like. Now you want to find out that whatever you have drawn is correct or wrong. Okay, so if you know So the first thing to check, look at the function, how many turnings you have. How many turnings you have? So this is the turning and this is the turning. So there are two turnings you have. So if two turnings, so of course what would be the degree of the function? It could be two turnings plus 1, which gives you 3. It means this is the graph of something like which has a higher degree, x cube. So if you take the derivative of x cube, you will get 3x square, and if you again take the derivative of 3x square, you will get 6x. And what is 6x? 6x belongs to a linear function, and linear function, we know that it can be drawn by a straight line, which you can see. So hence prove that whatever you have drawn is absolutely correct. Let's practice some more questions to clear the concepts and clear the doubts. Now, if you remember that just in the previous slides, we have this was the graph for f of x, and then we sketched the graph for f derivative of x, and then from the original equation we sketched one more graph for the second derivative. But what if the function is not given to you and you have been given directly the first derivative and you are asked to find the second derivative? So it means forget about this thing. You don't know anything about the function. You only have the first derivative, and with the help of the second derivative, you have to get the. So understand, if you remember that in the first derivative, this was what? This was our relative extrema. Now, when you sketch the graph by looking at the first derivative, this will be your x-intercept. That means it will change into your inflection point. So just find out wherever the point is giving you the slope of the tangent line as 0, that would be your x-intercept. Now, after that, look at this one. Okay, look at the first side. Here, the slope of the tangent line is decreasing. Okay, so if decreasing, so it means it should be below the x-axis. After that, the slope of the tangent line is increasing. It means it could be above the x-axis. So this is how you will sketch the graph by looking at the first derivative. It means here again you will apply the same concept of finding the graph how you did for the first derivative. Now understand that, remember one more thing, that concave down, okay, the concave down of the function represents the decreasing intervals of the first derivative. Look at the graph. Here it is f of x. Now, if it is f of x, you have to draw f prime of x. It means the first derivative you have to draw. So what is the first thing you will see? You will see where the slope of the tangent line is 0. It means you will get a horizontal line like this, or on these points you will get the horizontal line like that. These are your critical numbers. So you can see that here you have slope of the tangent line. At this point you have the slope of the tangent line 0, and at this point you have the 0 slope of the tangent line, and similarly here the slope is 0. So you have 4 points which will be made on the x-intercept. So I am going down to find and sketch my x-intercept. This is my first point. This is my second point. On the 2, it is my third point. And here is my fourth point. Okay, so these are the points where I sketched my relative minimum and maximum. Okay, after that, what I have to do? Second thing is I have to find out where the slope of the tangent line is greater than 0, it means positive, and where the slope of the tangent line is less than 0, it means negative. So positive, I will sketch positive, I will sketch the graph above the x-axis, and negative I will sketch below the x-axis. Okay, so look at this point before this and yani on the very left corner. Okay, so here the graph is increasing, right? So here wherever you will make the tangent line, it is above the x-axis. So above the x-axis means just draw it like that, above the x-axis. Now from here till the second, yani from the first extrema to the next extrema, the graph is decreasing. The slope of the tangent line is decreasing, or the graph is decreasing. Decreasing, it means whatever that you will sketch, it will be below the x-axis. Okay, now after this one to the second one, our graph is again increasing, or uh, I would have a slope with the positive line. Okay, so from this till this, I will sketch the graph like this. So something like that. Okay. Now after that, again from next, my graph started decreasing, so I will sketch it below the x-axis. Then again it started it increasing, so I will make it above the x-axis. Now let's just check that how much we are correct. Look at the turnings of the original function: 1, 2, 3 and 4. So x to the power 4 may be the degree. Okay, 1, 2, 3, 4. So 4 plus 1. So the function would have x to the power 5. If I take the derivative, I would have get 5x to the power 4. It means that the number of the turnings which I will get would be 3. So now check: 1 turning, 2 turning and 3 turning. It shows that I have made correctly. I have sketched the graph of the derivative correctly. Keeping in mind the same idea, if this is the graph of the function and you have to sketch the graph for the derivative. Now for the derivative, how would you graph? You have to find out, the first thing is inflection point. And what are inflection points? Inflection points are the points where concavity changes. It means concave up changes into concave down, or concave down changes into concave up. So how do we see? Those would be my x-intercept. So here I can say somewhere here is my inflection point, because this is concave down, here it is concave up, then again concave down. So here is my next inflection point. Then this is my inflection point, because concave down changes into concave up. So I will go down here. I will go a little bit down, and this is my first inflection point. Then this is my second inflection point, and this would be my third inflection point. I'm not making it by scale, just I'm trying to drop them down. Okay, so my concave down should be, this is my concave down, right? So concave down should be below the x-axis. Concave down, I have to make below x-axis, and concave up should be above the x-axis. So concave down from the very first inflection point, it is like that. Then concave up from here till here, so concave up should be like that. Then I have in the next concave down. So concave down again I will make it like that. Then I have again the concave up, which will gives me like that. Okay. After that I have to check. So again check how many turnings you have in the original question. So in the original question I have how many turnings? Check. I have first turning, second turning, third turning and fourth turning. It means my degree of the function is x to the power 5. If I have 4 turnings, I add 1 in the power, it will gives me this thing. So my first derivative will have 5x to the power 4, and if I see my second derivative, it would be somewhere like 20x cube. 20x cube means I should have 2 turnings because the turnings are 1 less than the function. So 2 turnings. Now check if I would have the 2 turning. This is 1 turning and this is my second turning. So it means that whatever I have made is absolutely correct. So let's try to sketch this graph. Okay, let's draw the axis. Here it's not very good, but anyway, it will give you the idea. Okay, so first of all we have to find our critical number. So at 2, this is our critical number. So here at 2 I'm making x-intercept. Then at 3 I have the critical number. So here at 3. Then at 5 I have the critical number. So I am making at 5. So this is 2, this is 3, this is 5. And then at 7 I have the critical number. So I am making on the 7 my x-intercept. That's all. Okay. So now the first from till 2, from 0 till 2, the function is increasing. Increasing means that the slope is positive. So positive should be made above the x-axis. Okay. After that one, between 2 till 3, so let's see here. Between 2 till 3, my graph is decreasing, which means that the slope is negative. So between 2 till 3, I will make the graph below the x-axis. From 3 till 5, you can see that the graph is increasing. It means slope is positive. So I will draw it, sketch it above the x-axis. Then from 5 till 7, the graph is decreasing, which means the slope is negative. So I will draw below the x-axis. Then from 7 till onwards, the graph is increasing, which means I have a positive slope. So it would be above the x-axis. And that is how I try to sketch the graph. So the number of turnings should be 1 less than the original function. So in the original function, I had 1, 2, 3 and 4 turnings. And in my first derivative, I have 1, 2 and 3 turnings. So it means I am on the right track. Now I am trying to sketch the graph of second derivative. Okay, so second derivative from the original graph. So from the original graph, I should see where are my inflection points. Okay, so inflection points are the point where concave up changes into concave down. So let's try again. Let me erase this all part. Okay, let me erase this part and let me start from the scratch. So here it is my concave down, concave up, concave down and concave up. So I'm trying to find my inflection point. So first inflection point, second inflection point and then my third inflection points are this. So the first inflection point between, so it would be here 2.5. So it is 0, 1, 2 and here 3. So it is 2.5. So this is my second derivative's x-intercept. The second one is at 4. I have the inflection point. So 3 and this is 4. I have the x-intercept. Then around at 6 or 5.8. So 1, 2, 3, 4, 5 and 5.8. I have somewhere here the inflection point. Okay, so concave down below the x-axis, concave down below the x-axis, and concave up I should draw above the x-axis. Okay, so the concave down till 2.5 concave down I have, so it should be below the x-axis. Then I have concave up till 4. So here it is my 4 concave up. It means I will make a curve like that. Then again I have the concave down till 5.8. So till 5.8 this is here concave down. So it means I will make below the x-axis, and then after that all is concave up. It means above the x-axis I will make. Now check from the first derivative. My number of turnings should be 1 lesser. So number of turnings in the f derivative are 3, and here the number of turnings are 2. It means again I am on the right path. Now I want to sketch my second derivative from the first derivative, and I want to check my answer, that whatever I have graphed from the original function gives me the same or no. So for that what I am going to do, I will look at the first derivative and I will find out the critical numbers from the first derivative. In order to solve for second derivative, I will find my critical numbers. So critical numbers are here. That means 2.5. Let me use another pen. So here that is 2.5 somewhere here. Okay, 2.5. It is not exactly, but let's check. Then between 3 and 5 here on the 4, I have the critical number, right? So here on the 4 I have the critical number. So this is my x-intercept. Then 5 to 7, somewhere at 6 I have the critical number. So at 6 also again I have a critical number here. Okay, so here the slope is 0, here the slope is 0, and here slope is 0. Now let's find out. Okay, so before 2.5 the slope is decreasing, right? This is decreasing. This is also decreasing. Decreasing means below the x-axis. Then again from 2.5 till 4 the slope is increasing. So from 2.5 till 4 slope is increasing. Then from 4 till 6 my slope is decreasing, so it should be below the x-axis. Then from 6 and onwards my slope is increasing, so it should be like that. And if you compare the two graphs up and down, they both are same. So you can sketch the graph directly from the function, then derivative, and then the second derivative, and from the function directly the second derivative, and from the first sum of derivative to the second derivative also. So I hope that you understood this concept also. Now if you want to practice this concept, practice as much as possible, and if you have any questions, do let me know. If you want to send me your work, you can feel free to send me the work in the comment box. I will check, and then if you have also any question, please write the comment so that I will get more practice questions in order to clear all your doubts. Thank you very much.